Tonight, when you step outside and look up, you'll see maybe a few thousand stars if you're lucky enough to get away from city lights, but here's what your eyes can't tell you. Behind those few thousand points sit roughly 100 billion more stars in our galaxy alone. And our galaxy is just one of an estimated 2 trillion galaxies in the observable universe, each one packed with hundreds of billions of stars of its own. Multiply that out and you get a number so large it stops meaning anything, something like 10 sextillion planets. 10 followed by 21 zeros. And out of every single one of them, as far as we can prove with hard, verified scientific evidence after more than 60 years of actively looking, we are it. The only ones. Not one confirmed signal, not one confirmed visit, not a single verified microbe from anywhere else. So what is actually going on out there? The answer isn't science fiction, and it isn't they don't exist. The real answer is stranger than that. And once you understand it, you will never look at the night sky the same way again. Before we get into it, if you like uncovering the hidden mechanics behind the universe and the human mind, this is exactly what this channel does. So go ahead and hit subscribe, because this one only gets stranger from here. Let's start with the explanation most people already half know but have never really felt the weight of. Distance. Our galaxy, the Milky Way, is about 100,000 light years across. A light year isn't a measure of time, it's a measure of distance. The distance light travels in 1 year, moving at roughly 670 million miles per hour. The fastest speed anything in this universe is allowed to move. So a signal sent from one edge of our galaxy to the other, even traveling at that absolute speed limit, would take 100,000 years just to arrive. And that's just our galaxy. The next nearest large galaxy, Andromeda, sits 2.5 million light years away. A real conversation, a back-and-forth exchange, is essentially impossible across distances like that. Even our closest neighboring star, Proxima Centauri, is 4.2 light years away. Send a signal saying, "Hello, is anyone there?" and the absolute fastest you could get a reply is 8.4 years later, and that's assuming there's even a civilization there capable of answering, which, as far as we know, there isn't. This is not a small inconvenience. This is the central, brutal fact of the universe we live in. It is so large that even moving at the maximum possible speed of anything in existence, getting a message from one side to the other can take longer than human civilization has existed. But here's the part almost nobody thinks about. Distance alone doesn't actually explain the silence, because distance assumes both sides are listening at the same time. And that assumption might be the biggest mistake in the entire search. The universe is roughly 13.8 billion years old. Stars have been forming and dying for almost that entire span. Humans, meanwhile, have only been broadcasting radio signals into space, mostly by accident, through television and radar, for about 100 years. 100 years against 13.8 billion. If you compress the full age of the universe into a single 24-hour day, human radio history would occupy less than the final thousandth of a second of that day. So even if an advanced civilization exists somewhere out there, the odds that its broadcasting window overlaps with ours, the right 100-year sliver lining up out of 13.8 billion years, are almost impossibly small. Civilizations could have already risen and gone extinct millions of years before humans climbed down from the trees. Others might not evolve for another billion years, long after the sun has swallowed Earth whole. We're not just looking across space. We're looking across time, and time might be the much bigger wall. But even that doesn't fully explain it, because there's a third problem. One scientists have only really started grappling with in the last few decades. We might be listening for the wrong thing entirely. In 1960, an astronomer named Frank Drake pointed a radio telescope in West Virginia at 2 nearby stars and listened for any artificial pattern hidden in the static. He called it Project Ozma, after the princess from the Wizard of Oz books, a land far away, hard to reach, populated with exotic beings. It was the first real attempt at what we now call SETI, the search for extraterrestrial intelligence. A year later, in 1961, Drake was organizing a small meeting on the topic and, almost as a joke, scribbled an equation on a napkin to structure the discussion. That napkin sketch became the Drake equation, a formula multiplying the rate of star formation by the fraction of stars with planets, by the fraction of those that could support life, all the way down to civilizations capable of communicating across space. Depending on which numbers you plug in, the equation can spit out anywhere from a handful to millions of communicating civilizations in our galaxy right now. For 60 years, almost all of that search has meant one thing: listening for radio waves. But think about our own trajectory. 100 years ago, humans leaked radio and television signals into space constantly and accidentally, loud and messy, like a radio left on in an empty house. Today, that leakage is already shrinking. We've moved to fiber optic cables, encrypted digital compression, and tightly focused satellite beams that don't spill out into the galaxy the way old broadcasts did. The noisy, leaky version of human technology lasted only a few decades before we quietly outgrew it. If a civilization out there did the same thing, its sloppy radio phase might have already ended thousands of years before we ever pointed a telescope in its direction. We could be listening for a kind of broadcast that an advanced species only makes for a brief, fleeting window in its history, then abandons forever, switching to lasers, tightly targeted optical pulses, or something we haven't even invented a word for yet. Radio isn't even the only method we've tried, and lately it isn't the most promising one. Over the last decade, a newer approach has taken over. Instead of listening for an intentional message, Telescopes like the James Webb Space Telescope analyze the chemical fingerprint of light passing through a distant planet's atmosphere as it crosses in front of its star. Certain gases, oxygen sitting alongside methane for instance, shouldn't coexist in a stable atmosphere unless something, possibly biology, is constantly replenishing one of them. It's not a search for a hello. It's a search for a chemical accident only life could produce. But this method only works on planets that happen to cross directly between us and their star from our exact angle in space, a geometric coincidence that rules out the vast majority of planets in the galaxy before we've even pointed an instrument at them. This is the question that's haunted scientists since 1950, when physicist Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory. They were joking about flying saucers, and in the middle of the conversation, Fermi reportedly stopped and asked one simple question: where is everybody? Given the sheer number of stars, the age of the universe, and the speed at which even a slow sub-light-speed spacefaring civilization could spread across a galaxy, the math suggests the galaxy should already be visibly, detectably full of life. And yet, when we look, there's nothing. That contradiction, the math says there should be aliens everywhere, the sky says there's nobody, became known as the Fermi Paradox, and it's been quietly unsettling scientists for more than 70 years. So if it's not just distance, and it's not just timing, and it's not just that we're listening for the wrong signal, what else is going on? This is where the explanations get darker, and a lot more personal. One possibility is called the rare Earth hypothesis, and it suggests intelligent life isn't rare because the universe is hostile to it. It's rare because the exact combination of conditions required for it is almost absurdly specific. Earth has an unusually large moon, which stabilizes our planet's axial tilt and keeps our seasons predictable instead of chaotic. Earth has a molten iron core generating a strong magnetic field, which shields our atmosphere from being stripped away by solar wind, the way it was on Mars. And sitting out beyond us is Jupiter, a planet so massive it acts like a gravitational bodyguard, pulling in or flinging away asteroids and comets that would otherwise slam into Earth on a regular basis. Even Earth's nearly circular orbit plays a quiet role, keeping our climate inside a narrow, livable band instead of swinging between extremes the way it would on a more elliptical path closer to or farther from the sun. Remove any one of those things, the stabilizing moon, the protective magnetic field, the bodyguard planet, the steady orbit, and complex life on Earth might never have gotten the multi-billion-year stretch of calm it needed to evolve. Under this theory, simple microbial life might be common throughout the universe. Intelligent, technological life, the kind capable of building a radio telescope, might be staggeringly, devastatingly rare. And then there's the darker possibility, the one that turns this from a curiosity into something closer to a warning. It's called the Great Filter, and it proposes that somewhere along the path from simple chemistry to a civilization capable of spreading across the stars, there's a barrier that almost nothing makes it past. The unsettling question is whether that filter sits behind us or still ahead of us. If it's behind us, if the impossibly hard step was something like the formation of complex cells, or the jump from single-celled to multi-celled life, then we've already beaten the odds, and the silence out there simply means almost nothing else ever got that lucky. But if the filter is still ahead of us, that changes everything. It would mean civilizations reliably reach our level of development, and then, almost without exception, destroy themselves before they ever leave their home star system. Nuclear war, engineered pandemics, runaway climate collapse, technology nobody learned to control in time. Under this version, the silence isn't comforting at all. It's a graveyard. Every civilization that ever reached our stage may have gone quiet shortly after, snuffed out at almost exactly the point of progress humanity has now reached, and we have no way of knowing yet which side of the filter we're standing on. There's one more strange thread worth mentioning, a single unexplained moment that still sits unresolved in SETI's history. On August 15, 1977, an astronomer named Jerry Ehman was reviewing printouts from a radio telescope in Ohio called Big Ear when he spotted a signal 70 times stronger than the normal background noise of the universe, lasting exactly 72 seconds, the precise length of time the telescope would have been pointed at that one patch of sky as the Earth rotated beneath it. Stunned, he circled it in red pen and wrote a single word in the margin: wow. To this day, the wow signal has never repeated, never been explained, and never been definitively dismissed as noise, satellite interference, or anything man-made. It remains the single most tantalizing 72 seconds in the history of the search for alien life, and we still don't know what it was. There's something worth remembering here too. For nearly all of human history, before streetlights and screens stole the sky from us, every single person who ever lived looked up at a night sky roughly 3,000 times darker than the one most of us see today, and saw the full, unbroken band of the Milky Way stretched directly overhead, close enough to feel. They didn't have the numbers we have now, the trillions of galaxies, the sextillions of planets, but standing under that much darkness and that much light at once, they almost certainly felt the same scale we're talking about, instinctively every single night of their lives. The silence you feel when you look up isn't a new feeling. It might be the oldest one humans have. So where does that leave us? For 60 years, we've assumed that finding aliens was a matter of looking harder, building bigger telescopes, scanning more frequencies. But the truth might be that the silence was never really about effort. It might be about scale, about timing, about a universe so vast and so old that two intelligent species crossing paths at the right moment, with the right technology, listening for each other in exactly the right way, is closer to a cosmic coincidence than a guarantee. Maybe the lights are on out there, scattered across the galaxy, and we simply haven't been standing in the right place, at the right time, looking the right way. Or maybe, just maybe, that quiet feeling you get looking up at the night sky isn't loneliness at all. It's the feeling of being early, of being one of the first instead of one of the last. We spent decades looking up and asking why nobody's answering. Maybe the better question, the one nobody likes to ask, is whether we're the ones who are supposed to answer first. If this is the kind of question that keeps you thinking long after the video ends, subscribe, because that feeling, the one where the universe suddenly looks bigger and stranger than it did 5 minutes ago, is exactly what this channel is built on. We go there every week. Next time, we go even deeper into the parts of the universe and the human mind that nobody bothers to explain properly.